This is Hallicrafters Rehabs. Welcome back. We're now going to go through a tracing of our Hallicrafters SX signal tracing, the Hallicrafters SX-100 rebuild. Now that the power supply and the power B plus is verified throughout the set. And so we need to trace the signal through it. By the way, my dad's doing well. He was, on Tuesday, he was a little stronger and he ate less, and on Wednesday, he was a little weaker and he ate more. So, no correlation there, that's just what it was. Okay, so before we begin, this radio's off, but we will be turning it on, and I have a scope here off the camera to the left, which we'll be doing some of the signal tracing with. Very high voltage stuff in here. Down at the bottom out of the camera shot is around the transformer. It's AC and high voltage DC, and all throughout in here high voltage DC. So if you don't know what you're doing, don't do it. Okay. So this is the antenna section, the RF section, and the oscillator section. And what we want to do is see if we got a signal. I have a RF signal generator off. Let's just move the camera over so you can see it right here. It's on 1,000, okay, and here is a signal tracer. So let's see what we can come up with. First of all, we'll put it on RF. There's a little bit of hum. Okay. And to verify we do get something, the RF signal generator is actually set on a low signal. So, going through the switch, this is band 1, band 2, band 3, and band 4. So we will put this on the input, the screen. Actually, it would be a whole lot easier if I just used a clip, which I have. Because we're going to switch through the bands. So I'm putting this on the screen to the RF amplifier tube 6CB6, I believe. And here is the. Alright. It's got a lot of hum because I got a very long. I had a real short one. Let me see if I can find it. Now I have it. It still wants to signal trace the world because it's ungrounded and I don't have a shielded one of these. But anyway, we'll flip through band 1. Let's strengthen this. There we go. And everything comes apart on me. Completely. Alright. Thank you. Okay, that was band 2. So we'll move this up to, and we have a signal. Band 3. Okay, there's signal. This is pretty cumbersome what I've got here. Let's work on this a little bit. Okay, that's a little more stable now. We can switch through. That's band 3. And then we'll go to band 4. And that's on a higher band. and we have a signal on there. So we can get signal from the antenna to the grid of the RF amplifier tube. So the next thing we'll do, turn this sound down so we don't hear a mess, and we're going to do from the plate of that tube to the grid, which is pin 1 and very hard to reach and hard to plug into. So let's see if I can get it in here. This is all powered off right now. I wouldn't be doing this like this otherwise. No power. Okay. And we're going to go from the plate. This is the wrong one. Here's the signal generator. We're going to go from the plate, which is here. Pin 5 is always plate on these 7 pins. Alright. Turn the sound up a little bit. Okay, we got signal on band 4. We'll go down. Signal on band 3. I'm going to have signal on band 2 too. Okay, that's band 2. And then we'll go to band 1. Okay, so we can get signal through the RF section of the coil and switch. Alright, so our next step will be to go, we'll turn this sound down. The gain is actually what it is. This is a Heathkit T3 signal tracer that I rebuilt about 3 years ago. Exactly the way Mr. Carlson's lab did it, and including his mods. And we'll go from the plate of the RF, which is where? Here it is, blue. Blue lead. To, that's the pickup, actually. I want the grid of the IF, which is right here, and the plate connections here. So plate, signal plate of the mixer to the, actually this is probably not right, anyway, I'm just going that way, to the oscillator grid, but when you get into the oscillator, it's a little bit more complicated than that. Anyway, we'll show that on the whiteboard. Nothing. It's a signal, but it's a general signal. It's actually not tuning. It was silent when we did, when I first, finished up with the B+, and we just listened a little bit, we saw it was silent. Okay, let's see if there's another signal somewhere. We're going to disconnect this, turn up the gain, and see if we can get a signal anywhere. It's a 6C4 anyway. Alright. Nothing. Let's see if we get it on another band. I may have to go to the oscilloscope at this point. Well, I'm learning right along with you. Right. So I am getting some resonance, even as crude as this is, between the grid of the oscilloscope. So we're going to, sorry about this, we're going to re-plug this back in. All right, turn the sound down because it's driving everybody nuts. Okay. We're going to come back to here. Hear that? I've got resonance on band B, or 2. Now go to 3. That may be the 1.650. Could it be? It could be. Okay, that's a very good signal on band 3. And band 4. I'm not even looking at frequencies. Yeah, that's band 4. Band 3. So we're going to go to the oscilloscope soon. Okay, so I've got some continuity, but there may be a real issue there with the signal from the band 1 oscillator. So what we're going to do is we're going to turn this off, and that way we don't get to hear the noise. Pull this out here. Alright, our signal generator is going to be set to come in through the entrance here, main entrance on the antenna. Okay. We're going to turn on the radio. Right now it's on band 4. We're going to set it about 18. A little bit of volume here. That's a really strong signal. We'll bring it way down. That's as low as I can get it. Nice signal on band 4. Okay. Band 3. That's on 6.8. Yep, got signal on 6.8. Band 2, 2.6. Signal on band 2, and we're going to see silence on band 1. It's an 800. there is a signal. All right. So I need a screwdriver, and I didn't even think about this. So let me get back. All right, I'm back. This is the band 1 oscillator. And we're just going to try and get a little stronger signal. We're not even concerned about dial registration yet. Because when you find the sweet spot of an oscillator coil, it's also the most sensitive. See, it's not even responding to that. That's interesting. No response at all. How about to here? Not much there. So, if I were to align it, I would move it to, there's signal there. Say 15. And it's way off. I think we're going to have to recondition these micas. Clean them out real good. It's not even responding to that. This one's stuck. Yes, indeed. Before we can even think about alignment, and we're going to have to get in here and clean these out. That's way too, it's the wrong size. They're stuck. All right. Huh. Okay. So, this radio is not ready for alignment. We got to get in here, get these things freed up a little bit. Clean out the wax. Still has the original wax in band 3 and band 2 over here. Unbelievable. So, let's get to work. I love it when a plan comes together. I don't know if you can see this or not. Let me see if I can get that down. it's really behind this lip. There's a trimmer. Maybe I can tip it. Let's see. There, you just see it right there. And I started probing around and seemed to isolate it around that trimmer. And so I started disconnecting things just to get to the point where I could check that, and it checked out fine, which gave me an indication that we have some kind of a short, inadvertent short, one of these bare wires or whatever. So I left it connected to my test instrument here, and then soldered everything back together, and now we have oscillation on the band 1, and it was just some sort of inadvertent short. I don't have any signal applied to it but noise, and you can hear the noise. Second problem we got to deal with is this pot that I worked on for the S meter. The S meter is not, this pot had a short in it, or an open in actually, and I tried soldering over it and so forth, but there's something still wrong with it, so we're going to have to check it out. I've got a spare if I have to use it, but I'd rather get this one working, so that'll be the next thing we need to do. So the problem with this potentiometer was basically that discontinuity was not repaired sufficiently by me, and so get my hands out of the way. So I put a bigger soldered ball at the point, and it's continuous all the way across, and it's working. Okay, so we'll put that back together and put it back in the set, if I can do that. And at the same time, let me go get the one that was no good. So these mica, the NPs, they're actually NP0 silver mic. They have a silver surface or so forth like that to change the capacitance. And this one is frozen shut. It just is. You can turn the mechanism, but you don't turn it. So I had some replacements. I've gone through, and this is the band 2. Put some coil dope on there. Reinstalled the 2 capacitors on the other underside here, and this one is working, and I'll demonstrate. Well, you really can't, because the other capacitors and the inductance sort of mess up the value, but it is a working capacitor. Let's see if I can get any kind of thing reading off of it. This is the wrong meter too. Let's see, Henry's. Okay. Capacitance. It's trying to find capacitance. This is really absolutely the wrong meter. Let me go get the right one. Alright, when I've got capacitance and inductance in parallel, it's makes it kind of squirrely. But you do get an inductance reading, which means everything is continuous. Do I get a capacitance? No, probably not. No, it doesn't want to do that. Okay. So we'll put all this back in. All right. I've replaced these 2 frozen trimmers that were in here with some ceramic ones, actually. I think they are. And service the S meter adjust. Let's see if we have a radio. I have an antenna too, by the way. Sounds the same on band 1 and 2. Pretty weak on band 1. Oh. We also don't have it aligned, but pretty way off as far as so we'll see if this is enough. What about band 2? Well, we got some signal there. Oh! I left out the little ferrite core that goes in there. Let me put that in. Okay, the little ferrite core in there is necessary, and you have to remove it in order to get it. Let's see. So this is band 2. It was deep in there. Notice how strong things get. All right, so the new trimmer's working good. So let's go to band 4. All right, let's bring it up. Not sure where we are. Oh yeah, that was the wrong channel. All right, let's see if this is working. I believe it is. Nicely. Okay. So, and the S meter, you can't see it with the camera angle. Maybe we can. Really hard to see, but it adjusts. Let's take this off. But it adjusts nicely. I can get my fingers back there. I got the interference with the... I can't get my hands back here. There we go. There's the adjustment right there. Okay. So, lunchtime. Still haven't addressed the selectivity filter problem, and I'm a little bit disappointed on band 1. Let's take another look at band 1. Alright. Okay. It's just not aligned. That's the issue. It should be way off based on. I can't get my screwdriver into that C52. It's almost going to come out. I better screw it back in. All right. Yeah, we've got some issues there still. So we'll come back to this. Okay, so I've done a lot of testing. Bands 2, 3, and 4 work well. Let's move this over here where you can see. Bands 2, 3, and 4 work well. This is still not oscillating in band 1, so we'll have to rebuild this. The oscillator box for the second IF there's still a problem. A real close look at the resistance chart show that they're not reading 100K on pins 6 and pin 7 like they're supposed to. So that's probably the reason why we're not getting oscillation on the lower side band. And there's still a problem in here. I think we're okay with this switch right here, but the 5 kilohertz is not working. I think I may have an incorrect capacitor substitution. So step 1, we're going to have to take this box out again for maybe the 5th or 6th time. No problem, but getting used to it. So that's our next step. Okay, so this looks like a train wreck, doesn't it? There's the oscillator box there. These are all these wires that are temporarily reconnected in here. Here's the switch with the corrected values of 0.004747. You can't see the schematic's too small, but 0.0047 microfarads as opposed to 0.047 microfarad, which is what I had installed originally. And now when you rotate the switch, you get the varying capacitances in order of more and more and less, depending on what size bandwidth you want. So this is fixed. This I spent a little more time working on color coding so that when I put it back together it will work good. Somehow, somewhere, it wasn't giving me the right, responses, but everything tested out in this temporary, with the wires connected temporarily. Now we just need to put the box back in, tie it down, reconnect, splice the wires, and I think it will work this time. Still have to do the oscillator section, but that's where I'm at for today. That's it for today. Fine. Well, it's hard to believe, but it is progress. This reassembly or reattachment of the oscillator box was successful. Everything, all of the ohm values test out properly, and so I think we'll probably get oscillation on the lower side band. I'm an optimist. I think at least I put a couple extra terminal strips in to make it easier to take the box out in the future. But I'm an optimist. I think it will work. As for the oscillator, I mean the band 1 oscillation. Now I can't find here it is. This is supposed to be a 50 picofarad, and it was measuring about 10, if that. So that was across the trimmer capacitor, the mica trimmer capacitor. And so I'll replace that, and hopefully we'll get band 1 after this. I'm exhausted, so I'm going to relax, and we'll continue this later on this week. We'll see you next week. This is Hallicrafters Rehabs. Thanks for watching, and thanks for new subscribers.